In this exercise, we have a ball which is thrown exactly horizontally. So the initial velocity is exactly horizontal from a height h of 18.3 meters. And we are also said that the final velocity of the ball when it hits the ground is 3 times the initial velocity. So we can say that V final is equal to 3 times V initial. In part A of the question, we need to find the vertical component of the final velocity just before it hits the ground. So in other words, we need to find V final y. So if we introduce x and y axis, we are looking for the projection of the V final on the y axis. So this V final with the subscript y, the vertical components of the final velocity. So to do that, we first know that the ball is moving with a constant acceleration, which is g. So we can use the equations that we have for linear motion for constant acceleration. And one of them says that V final square is equal to V initial square plus 2a delta x. This is the general form of the equation, but if we apply it to our case, what do we see? We see that, and let's use this equation for the y components only. What is our V final y? Well, that's what we're looking for, so we can just say V final y. What is our V initial y? V initial y is equal to 0, because it has no vertical component when we start, plus 2a delta x, plus 2, and instead of a we have g, and instead of delta x we have this h. So you can say that V final y is equal to simply 2g h. So if you calculate this, this is 2 times 9.81 times 18.3 square root, and this gives us 18.9 meters per second. So now we found the vertical components of the final velocity just before it hits the ground. So in part B of the question, we need to find the initial velocity of the ball. So we're going to need this. So let's say that this is our V final y. Well, we know that V final is equal to square root of V final y squared plus V initial V final x squared. Well, what do we know about V final x? V final x, or the x projection of the V final, is the same as V initial, because initial velocity is exactly horizontal, and in the horizontal direction we don't have any acceleration, so the x component stays the same. So in other words, V initial is equal to V final x. So we can say that this is equal to V final y squared plus v initial squared. On the other hand, we know that v final is equal to 3v initial. So we can use these two equations. We can now erase this. So we have 3v initial equals v final y squared plus v initial squared square root. If I take squares of both sides, I get 9v initial squared equals v final y squared plus v initial squared, or 8v initial squared equals v final y squared. So v initial is therefore equal to v final y over 2 square root 2, which is then equal to 18.9 over 2 square root 2. And this gives you 6.7 meters per second.